Okay, let's look at the homework 4.1, 4.2, problem number 6. Alright, so we want to find the critical numbers of this given function here. Alright, so let's do that. Alright, so in order to find a critical number, we need to find the derivative. So f prime of theta is equal to, right, so it's a 18 is just a constant multiple, so put that here, and derivative of cosine is negative sine of theta, right, and plus, right, there's 2, so put 2 in front, so 9 times 2 is 18, then you have a sine of theta, and then multiply by derivative of sine, so it's going to be a cosine of theta, so just a changeable. Right, then we need to factor out common factor, so 18 sine of theta, right, then from here we have negative 1, so I'll put it right here, minus 1. Right, so if you factor 18 sine of theta, you get cosine of theta. Right, so we're gonna set this equal to 0. Right, there are a couple of things that we can get from here. So we can make sine of theta. So we're looking for theta that makes either sine of theta equal to 0 or this guy equals to 0, which means that the cosine of theta equals 1. Right? So sine of theta is 0 when theta is, right, 0 and pi, or actually negative pi as well, so plus or minus 2 pi and so on. So a good way to write that would be any multiple of pi, so I'll say n pi, right, where n is any integer from there. Right, and the cosine of theta would be, right, cosine of theta is 1 when theta is 0 and plus or minus 2 pi and so on. So that's a good way to write that would be any multiple 2 pi, so it's going to be 2n pi. Alright, but the 2n pi is actually included in n pi, so it's going to be simply n pi. So let's type it in. Alright, so this is going to be n times pi as a Greek letter. Alright, there should be pi here. Where's pi? Right, n pi. Alright, so let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.